Hello and welcome to my prompt engineering handbook. I designed this session for Python coders who wanted more, more accurate output out of their LLM prompts, and for people who wanted to understand, what really prompt engineering is. So let's jump right in. Everything you're seeing here is in the Word document that's on the GitHub repository, so you can download that and follow along. It will be in the comments section. So a prompt really it's a meeting of your understanding of the question and what the LLM's understanding of the question is. Today, as this is being recorded, you have to go to the LLM. It really is not smart enough to understand exactly how you construct sentences, the words you use. You have to come to it. And that's really where the engineering part comes in, is structuring your prompts in a way that you'll get what you want back out of the LLM. So a basic example here, using the question, who's the president of the United States? In step one, we have the user making the prompt. That prompt is brought into the LLM's context window and tokenized, meaning the words and word parts are created and changed into mathematical representations. In step three, the LLM matches that prompt to its internal weights, or the way it's stored the data it was trained on. And the output comes back in the context window as the response. If you want to read more about this, check out this article called "Attention is All You Need." It's a wonderful understanding of how LLMs are created and how you can interact with them. From that great document, "Attention is All You Need," I've just printed out a little mapping here from what's called the attention layer. And imagine, if you will, how the word law is mapped. So you see here the color, the density of the color, the darkness of the color reflects what words map to law. So the law will never be perfect, which makes perfect sense, right? You need to think in terms of how the LLM is mapping words together. And I'll give you some tips and tricks on how to do that. I'm not going to go through the whole document. You can do that on your own. So we're going to skip through how to construct prompts. We'll be touching on that in our examples. The prompt format, punctuation, bullet points, things like that are important. And the context window is really how much can you put in the prompt and still expect it to remember what you're saying. So let's skip down to probabilistic versus deterministic, which is really important. And Mark Twain said it long before the LLM came along. It ain't what you don't know that gets you in trouble. It's what you know for sure that just ain't so. And this is a real concern with the rise of LLMs, in that the difference between a probabilistic versus a deterministic understanding of the universe. Let me give you an example. So if I ask a deterministic question, I'm researching that. I go to the Pandas, which is a Python package for manipulating data. And I read on this website, the Pandas user guide, I read how to make a data frame and then how to group that data frame by certain columns. And that's all laid out here in the code. Makes perfect sense, can be replicated. It is coming directly from the creator of the original Pandas package. It's deterministic. It'll always be the same. Every time you cut and paste this code into Python, it's going to give you the same example. Over on the left, we have a probabilistic understanding. So we've written this long paragraph, which is a prompt, on how to do the exact same thing, ending in grouping the data by column A, and then summing columns C and D. When you put this into an LLM, you'll get a different response every time, and a different response for each different LLM that you use. So it's not really fact, it's probabilistic. And you can test this just by saying into any LLM, what's the best Python package? You'll get a different response every time. And it might be small, in terms of the packages changing or their order changing, but it's not a deterministic view. And just want to be real careful taking, what is presented as fact when it really isn't. So read about that here. Let's keep going. Here's the examples and how to construct prompts and things like that. So let's skip down. You can read that in your own time. We're going to skip down to an example prompt. We want to design a Python script that visualizes survival rates of passengers on the Titanic based on their class. We're going to utilize a pandas library, again, for data manipulation and matplotlib to plot who survived from each class. Just for those of you beginning in Python, the Titanic data set is a wonderful data set. It's what many of the tutorials are based on, and I would highly recommend downloading it and looking at it. We're going to look at it in more depth in just a minute. So we step through this prompt, very specifically designed to require the right libraries. We already have the Titanic CSV in our working directory on our computer. We're going to calculate and manipulate the data into percentages of who survived from each class. Then we're going to visualize that data in a bar chart. And we're going to add some annotation to the chart. And the whole idea is that we are being very specific in what we're looking for. And we're giving the LLM what it wants. We're speaking in its language, not leaving anything to guess. I've detailed below what goes into a good prompt. So you're stating the task clearly. You're specifying libraries, error handling. You want to verify what was done. So these are the things you want to look for when you're creating a prompt. So here's our output, and let's switch over to Python so we can see what happened. This is the output from that prompt. You can see we have our libraries loaded. I'm not going to get too deep into this, but I think it's handy just to give an overview of why it's doing certain things and what the comments mean. So we're creating our bar chart, and it's survival rates by class. We're putting titles in there, and the output at the end is survival rate by passenger class. We didn't get any errors, which is wonderful. It means, the prompt told the LLM exactly what it wanted to do. You can see here that unfortunately, people in third class only had a 24% survival rate, while first class had a 62. And again, this is one of the values of having the Titanic data set. It is fairly interesting, and it's sort of the universal way to learn basic data manipulation in Python. So let's get back to the Word document. So we made our prompt. Now, let's talk briefly in the time we have left about a very powerful concept called reverse prompt engineering. So what you want to do is give the LLM the output as the first step, and then ask the LLM to generate the most accurate prompt it can from that output. This way, you'll get exactly the language that the LLM wants to hear to construct any new prompts on that subject. So what we're going to do in the exercise is write a Python script that creates new features of family size and title. Title meaning each person in the Titanic passenger list had a title, Mr., Mrs., Doctor, things like that. So we go grab the data set. I got mine from Stanford. I put it in the working directory. Okay. Here's what it looks like. You have survived, what class they were. So Mr. Owen Harris, unfortunately, did not survive because he's a 0. He's 3rd class, male. He was 22. There was a sibling or a spouse on his ticket. We don't know whether it's a sibling or a spouse. There were no children, and he paid $7.25. So you see here, a first class ticket is $71 back in 1912. So let's get going with the reverse prompt engineering. So what we want to do is, first step is to create the family size column. So we know by looking at the data, we're going to add the siblings and spouses, the parents and children, but the twist is that we need to add one extra for the actual ticket holder who's not represented in the siblings or parents and children columns. So here we go. We're going to do a Google search because we know it's pandas, and we want to do a Google search for adding a numeric variable together in a new column. We want to add columns together. So back comes this piece of code from that search. And you can see here they're using a data frame called df. The new column will be sum columns. And we're summing column 1 and column 2, which is pretty much what we want. It's just not set up for the Titanic data set. But that's easy. So let's ask the LLM how the ideal prompt would be structured if we asked it to create this line of code. So we're going to give it a persona. You are expert prompt engineer. Please write me an ideal prompt to create this Python code. And it's the same that's highlighted in yellow. Comment out for a beginner so I can see the logic that was used to create the code. So it returns the following prompt. It's not giving us the code back. It's giving us what's the ideal prompt. And interestingly, pay attention to the language that's used. It's not an expert. It thinks it's a programming assistant. I need a Python script. It's not being polite, which is fine. And so what's it doing? I want to create a new column called sum columns, which is represented in the code from columns 1 and 2. Additionally, interesting choice of words. So in addition to doing the code, comment it out so a beginner can understand each step. I take this prompt. Now I have something that I know the LLM will understand, and I modify it to suit my needs. So I don't want the data frame to be just DF. I want it to be Titanic DF. I want to call the new column family size, and I'm adding siblings and spouses to parents. Then I've added this, take that addition, but then add a 1 every time to get the individual passenger represented. Okay, additionally, detailed comments, just like the LLM told me to do. So I put this prompt in, back comes this code. It's a very simple example. What I'm trying to demonstrate here is that if you want to give the LLM every advantage you can to return the most accurate information, this is a way to do it. And it's given us the Python code to do exactly what we want using the variables that we've given it. And it's also commented the code out in a really nice way that helps us understand. So now we're going to save this. And by the way, Notepad is your friend because it allows you to create the different formats, bullets and things like that, returns that you don't get in the entrance window of an LLM, and you can save things and recycle them. So that's how we created that. I'm not going to go through every little part of this. The next step is to extract the title, Mr. or Mrs. We're going to use the exact same formula, the exact same approach to get that work done. You can see here when we do the Google search, it comes back with what's called a regex expression, which is very handy for manipulating text. You don't really need to understand it because it's explained in the comments. So once we get that, now we have the working title extract information. We're going to put all that together, take the specific code that we got back at each step in task 1 and task 2, family size and title, and then put it into a larger prompt that's structured in a similar way to the example that we just gave, broken up into 2 tasks. The goal, again, is to get new columns with siblings and spouses added to parents and children +1 to get family size. And we're going to want people's titles. So back to Python, we're going to put this in. Out comes our output code. We're going to go to Python and check. So here we are with the output from our integrated prompt, putting together all the pieces of creating the family size variable and the title variable. So let's step through real quick. We're picking up the Titanic data set from the working directory, the directory where your Python code is. We're going to print it and show it what that looks like, just to show the unaltered version. Then we're going to start creating our new columns. So here we have family size, which is siblings and spouses plus parents and children +1 for the ticket holder. And we derive this code from our reverse engineering prompt, our reverse prompt engineering example. Then we're going to print out that and see what that looks like. Then here is our title, new column. It's called title. It's done by taking everything to the left of the first period, so Mr., Mrs., and then creating that into a new column that says title. We're going to print that out and look at that as well. So let's see how it worked. And here's our response. We have the data set before we touched it. And a little note here, you can see the tremendous discrepancy between fares. One person paid $7, one person paid $71. They're in first class. The other person was in third class. Let's scroll down a little bit because our output's a little too big. So the family size column, and let's use Mr. Owen Harris. He had a spouse or sibling aboard, and his family size is 2. So that makes perfect sense. Okay, that looks like that calculation was done right. The title column, so again, Mr. Owen Harris, title, Mr. scraped off of his actual title, and we can check other people. They appear to be accurate as well. You'd probably want to print off a little more than this just to validate how the process went. So after all that, let's see what these new variables do. How do we look at them? What did they add to the story from a data science perspective? So I made this scattergram, okay? And what it is the vertical is a log scale of the fare. And that is important that I say log because the differences are so huge. If you log the number, you shrink the distribution of that number, and it becomes easier to look at in a chart. It also has value from a data science perspective. And then I have family size going left to right with families or single passengers over on the left to families up to 11 on the right. Red indicates did not survive, green survived. So it's a pretty interesting little chart here because you see over on the left with families of one at the bottom where third class people are, they're mostly red. At the top, they're all green. As you march over, as family size increases, interestingly, you start to see more red dots. And after 5, 6, 7, it's almost all red. My theory, and I would invite someone to prove me wrong, is that these red dots represent the patriarch or the father of in a family, a large family, probably third class, traveling, who did not get on a lifeboat. So the dots are individuals, they don't represent the entire family. My guess is these are all dads that did not get on a lifeboat, which is pretty sad, and something you can discover by looking at the data. So thank you so much for sitting through this. One of the things I wanted to talk about quickly is you can reverse engineer all kinds of things, and one of them might be, other than code documents, something like a presentation. So say you wanted to reverse engineer a presentation. And I tried to do that. Here's a suggestion for you. Here's my prompt to create the ideal prompt. Write me the best prompt to create a Steve Jobs presentation based on his presentation principles shown here. And then below are Steve Jobs' core presentation principles. So the whole idea is you're telling a story. You have a good and a bad guy. You're using analogies, things like that. And what came out of this was the ultimate Steve Jobs presentation prompt. So what you would do, just like we did with this code, is cut and paste this. And you might want to just concentrate on one particular slide, like the title slide or something like that. And here you can see it's leaving places for you to insert your content. So instead of selling the world's thinnest notebook, you might want to say, I'm selling, the best insurance policy or something like that, and let the prompt do its magic there. Thinking about non-code examples, things like contracts and stuff like that would probably be easier to reverse engineer than a PowerPoint presentation. You again would want to think in small chunks, like individual slides or paragraphs at a time as you do that. Thank you so much for listening, and please stay tuned for more of my videos. If you enjoy them, please say something in the comments or like it. I really appreciate it. Bye-bye.